So now let's extend our understanding of the conversion between moles and particles to elements in a compound, right? This is just one more small step forward. What we're going to do is we're going to say, all right, so let's take an example, aspirin. Aspirin has 9 atoms of carbon for every molecule, 8 atoms of hydrogen for every molecule, and 4 atoms of oxygen for every molecule. Right? But for every mole of molecules, it has 9 moles of carbon, 8 moles of hydrogen, and 4 moles of oxygen. Right? So basically what we're saying is it's 1 to 1. Right? That's all we're doing here. So we're just going to make one more conversion in it. And, we've seen this before. We've seen this kind of language before. The subscript means 9. That means 9 parts per one part of aspirin, right? So if the part is a molecule, it's atoms. If it's a mole, it's a mole, right? It's 9 to 1, 8 to 1, 4 to 1, and so on. So let's do an example. If we, since we know that, we can set these conversion factors up, right? Here's 3 conversion factors that we can get, actually 6 conversion factors, because it depends. If we're going from moles of aspirin to moles of carbon, we would use this. If we're going from moles of carbon, 2 moles of aspirin, we would use that one. You've used your conversion factors before, right? So here's 6 conversion factors we can get out of this, and let's finish this conversation with a learning check. All right, so set this up, make an attempt at it, and then come back and check your answer against mine. Pause the video and come back and check your answer against mine. Okay, so I'm going to suppose that you paused it, and I'm going to say that I'm looking for atoms of oxygen, right? And I'm going to try to get a straight line here. Maybe if I used a straight edge, would that be possible? No, I'm going to try using a straight edge here. Oops, so I'll get down here. Let's try right there. There you go. Wow, what a nice straight line, huh? Okay. And some not so straight lines. Atoms of oxygen. Now we know that there are 4 atoms of oxygen for every molecule of aspirin, right? But I think I'm going to go, atoms of oxygen to molecule of aspirin. I'm going to call that aspirin. ASP, okay? And I know that there are right, 6.022 times 10 to the 23rd molecules for every mole of aspirin, right? So there are 4 atoms of oxygen, because there's a 4 right there, 4 atoms for every molecule, right? And I have, how many moles of aspirin do I have? 0.15, so let's go back here and say moles of aspirin. So it's 0.15, 0.15, 0. Handwriting is horrible. Moles of aspirin are going to cross off. Molecules of aspirin are going to cross off, and atoms of oxygen are going to they're not going to cross off. It's what we wanted. We don't want to cross those guys off, right? There we are. And so it looks like the answer is going to be 0.150 times 6.02 times 10 to the 23rd times 4, which is going to be 4 times 0.15. I can do that part in my head. That's 0.6. 0.6 times 6. Okay. I mean, this is going to be almost math we can do in our head. I'm going to that's 0.6 times 6.02 times 10 to the 23rd. And so it's going to be about 3.6 times 10 to the 23rd, right? 3.6. There's 3 sig figs, so I can't leave it at 3.6. It's going to be 3.60. Let's do this. 6 times, 0.6 times 6.02 is going to give me 3.61. Oops, 3.61. 3.61 times 10 to the 23rd. Okay? atoms of oxygen. Hope that's helpful. I'm falling into the habit of saying now, we are going to get much more practice in homework. All right, good luck.